Hidden in the mists of the South Pacific, on one of the most remote islands on Earth, is a mystery locked in stone. Giant human forms stand against the weathering of time. These are the mute sentinels of Easter Island, stone statues called moai. Roughly 900 moai were carved over a period of 500 years, hewn with stone tools from the volcanic rock of an ancient crater. No one knows how the many-ton statues came to stand at their sacred sites. How could an isolated culture with only the simplest tools move monoliths from the quarry to sacred platform sites scattered all over the island, some of them 5 miles away? Legend says the statues magically walked to their venerated platforms. To penetrate beyond the myths, Nova assembles a team of archaeologists, engineers, and the Easter Islanders themselves. Together, they launch a series of hands-on experiments to explore the methods used by the ancients. But no one anticipates the events that unfold.
We want to go little by little.
Ideas clash.
No, and I go by the statue because the angle is different.
Tensions escalate as new methods are presented.
I've got 12 people moving 6 tons. You didn't do that.
That's 65? No way.
Resources run out, just as they did in ancient times.
What are we going to do, fight over it?
This is the legacy of Easter Island, a culture that exhausted itself in moving giant stone. How did this ancient society achieve such monolithic greatness, and why did it fall? Easter Island, now known as Rapa Nui. Today, treeless, windswept land rises from an infinite sea. Just 7 miles across, Easter Island is studded with volcanic craters which provide the raw material for the stone sculptures of the past. For 1,200 years, the island culture thrived in isolation. The population may have reached as much as 10,000. It was a closed society. As far as is known, nobody came to the island, and nobody ever left. There was no recorded history. And all that remains is a thin thread of oral tradition that is passed down through generations. We do know the ancient islanders feverishly expressed themselves in stone. According to island folklore, the moai are the spirits of powerful ancestors. They were raised on platforms called ahu, which were the centers for ancestral worship among the island's clans. But as population grew on the tiny island, conflict erupted between the clans. Food and timber were scarce. The people stripped the landscape of its once abundant trees. Today, only thin soils and exposed pastures survive. Could it be that this remote civilization ultimately destroyed itself over the moving and raising of their sacred moai? For decades, theorists have come to the island to try their hand at moving moai. In 1955, Norwegian archaeologist Thor Heyerdahl tried to drag a 9-ton moai on a small tree fork over the ground. The pulling method worked, but dragging a heavy statue is likely to damage the carved stone. Heyerdahl returned in 1986 inspired by Rapa Nui folklore. Legends say that the human statues walked across the island to their ahu platforms through a spiritual power called mana. Heyerdahl tried walking the 9-ton statue by rocking it forward like a refrigerator. Although it works, the method is precarious on anything but level terrain. Thousands of tourists come to gaze upon the stone giants and wonder how the Rapa Nui people moved and erected them. Dr. Claudio Cristino has been Easter Island's resident archaeologist for the past 20 years. He takes Wyoming architect Vince Lee to the largest ahu on the island. It was one of the ceremonial centers on the East Coast. In 1960, a tidal wave struck the ahu and washed the 15 massive moai inland. Claudio was in charge of restoring the site.
Yeah.
The statue was broken, was decapitated.
I see.
And just the head was 27 tons.
The head alone?
Just the head.
And you had to put it back on and cement them together somehow?
Yeah, with no...
Vince's expertise is Inca stonework. He has explored how the Incas moved heavy stones and is intrigued by Rapa Nui ingenuity.
Is this more like the finish that they had when they were first made? In other words, most of them that you see now
more
are...
like here.
Oh, I see. Very smooth. Yeah, sure.
That's by 1%.
And all of this is erosion due to weather over the years. They vary in size, but this one here at the top knot's got to be pretty big. How many tons is that?
65 tons.
Wow. And is that how you erected these, with a crane?
With a crane. With a crane, with 50 people, with ramps, with poles, with levers. So this gave us, for the first time, a quite clear idea of the incredible energy that was used in the past.
Even with modern equipment, it sounds like it was a huge project.
Even Vince and Claudio have trouble imagining how an ancient culture could have carved, transported, and erected such mighty stones without the aid of modern technology.
The meaning of the moai, to me, as an outsider to this island and to this culture, is ancestor. It's the link with the past. The meaning of the moai is family.
Archaeologist Joanne Van Tilburg is here to test her theory of how the moai were moved. For 15 years, she has searched for the cultural significance encoded in the moai.
When Rapa Nui people look at these statues and think about these statues, they are to them as if they are indeed living beings.
But with no written record left behind and only limited clues from archaeology, the question of how the Easter Islanders moved their moai remains elusive.
Science and mysticism, religion, faith, archaeology, engineering, all of these things are trying to come together here to understand what, when you look at it, is a relatively simple object. It's big, there's no question about that, but it's so beautifully designed in its simplicity that it offers us the possibility of answer, and yet the answer is so deeply embedded in the culture, and much of that answer, unfortunately, has been lost.
Joanne has measured the height, width, and estimated weight of each moai on Easter Island. Her inventory of measurements created a digital model of a statistically average moai.
And
so
the computer data helps Joanne and robotics expert Zvi Schiller formulate their theory on how the ancients moved the statues.
Turns out there was some mistake there, but so this is
By digitizing a topographical map of Easter Island, Zvi simulates the undulating terrain. This virtual fly-through shows them a view of the island from the perspective of a moai in transit.
It's up
and down.
This is where we actually, this is the new part. And
from this digital model, a full-scale replica will be made for experiments on the island. Joanne proposes laying the statue on a triangular-shaped sled and then pulling the moai and sled over logs that roll along wood tracks.
safe for the statue, it's comfortable for the statue.
Our team of
the statue
experts
is
has
calm.
gathered on the island to
So
put
that's
their
the
theories
fit
to the
for these
test.
rigs. The best way to fit them is standing them up.
They will first try Joanne's log roller method.
Come back and get it at another time. That's an option. It's a
And the other
reasonable
thing,
option.
Claudio will be in charge of raising the moai.
And the people that study this culture for years know that any of these events was part of a very complex religious process that took years. I mean,
Vince is the only member of the group who has explored how another ancient culture, the Incas, moved heavy stone.
From an engineering standpoint, a triangle is the simplest.
While engineer V. Schiller has simulated moai transportation on his computer, he's here to see if his solutions will work in the real world. Rafael Rapu, a Rapa Nui sculptor, will be the foreman for the project.
What's the height?
we don't care.
That's not important.
That's not important.
Joanne's architect husband, Jan, demonstrates Joanne's moai moving
Before we
method.
do that, the tracks are a little bit of
A triangular A-frame sled will be placed on logs that will roll over rails.
And then you just pull this forward, and when you run out of a roller, we're going to put another one there. You run out of a roller.
They have their method. Now they need a moai. A concrete mixture of sand and stone from the island is poured into a fiberglass mold scaled up from Joanne's digital model. It is as close as the team can get to using a moai without risking damage to an actual statue. Three days later, the 9.5-ton concrete moai is ready to be lifted out of its curing pit.
It's a wonderful thing to see this thing being born like this.
Even with the aid of a crane, the moai is an unwieldy object.
Sounds good. Drop it down and pull it back. Exactly right. Hey! Discussion.
Now with this little roll.
With a boom. He's going to do it with a boom.
Chainsaw surgery frees the moai from its fiberglass mask.
All right. Tip her over.
From a digital computer image to a concrete facsimile, this moai is the culmination of years of Joanne's research.
People call me the mother of the moai, and right now I feel very fond of that object. So I can see how people would invest family histories and family traditions in something like this. It's very easy to do.
More than half of Easter Island's moai are still at the quarry, known as Rano Raraku. It is a mountain of hardened volcanic ash. Here the moai lie in various stages of production. Some half-carved, some on their backs, as if sliding down the quarry slope, and others buried from carving debris and erosion. Rafael Rapu comes from a long line of Rapa Nui carvers. He takes local sculptor Santi Hito to the high slopes of the quarry to explain the techniques used by the ancient carvers. They sculpted moai from the bedrock using a stone tool called a toki. The largest moai on the island, named El Gigante, the giant, was never finished. Its partially carved figure provides a glimpse into how the moai were carved. Continuing the tradition of Rapa Nui master carvers, Rafael passes on the oral history to Santi.
His words came from the elder people when he was a young boy. And so it transcends from them to him, as is right now. Like you can, witness how it transcends to me, and hopefully eventually to my kids and so forth.
Raphael explains that first, channels were carved around the body of a moai.
He thinks that 20 people carved this moai over a period of time of 5 to 6 years to this stage. This is our sections of people who were, given, as your assignment. This is your section. You can carve, and you can see different, ways of doing it, and you can clearly see the talkie marks and how the people were carving and going in and make these deep cuts in the rock like this, that.
The channels reached around and eventually formed a boat-like keel until the statue could be snapped off and fully extracted.
This quarry was established around 900 or 1000 AD. And for a period of at least 500 years, maybe a little bit more, most of the statues that we know about were made. Well, this is a large statue of over 100 tons. This massive statue was in the process of being moved downhill. It's already detached from the mother rock, and it's extracted from the quarry, and it will end at the foot of the hill into a prepare hole to put it in a vertical position. This monstrous monolith needed certainly hundreds of people to move them downhill, to transport them to distant sites all along the coast of the island.
At the base of the quarry slope, the moai were erected in prepared holes so the carving could be finished.
Immediately coming out of the quarry, they came down to a prepared hole, and you can see here the remains of the keel. The main purpose to put the statues in this hole was to finish this section, and they built a very sophisticated wooden frame that was attached to the statue while standing. Then probably using soil, dirt, this debris from the carving process, they built the mounts and the ramps to move it down slope. So actually, the statue will go face down, head first, on top of the rig, and we start moving on these several roads along the coast of the island.
The replica moai is brought in by truck and crane to the transport site. A traditional Polynesian ceremony called an umu tahu is held. The priest's blessing acknowledges that working around a multi-ton statue can be dangerous.
So it's a benediction on behalf of the Catholic Church and this community for this project and the work that they're doing here to take care of everyone.
Joanne's A-frame sled is ready for the moai. Its unique triangular shape is proportioned exactly for the statue. The team will try to pull the entire rig 100 yards on flat terrain, using Joanne's log roller system. The log should roll over this track of thin wood rails.
We're going to move it 5 meters, and then stop. And then we're going to regroup, talk about it a little bit, and then we're going to move it. Probably we'll move it to the end of the rollers, and that's the first day. Oh, yeah.
Joanne confers with Nico Hawa, who is in charge of the Rapa Nui pulling team. He rehearses his commands before they begin.
We're pulling on terrain that's flat as a pancake here, and that's the easiest situation. That's where I'd start out, too, to test the idea. But if it's got to be valid, it's got to be something that would work on going up hills and down hills and side hills and stuff like that. I think this system would be a little harder to do on that kind of terrain. But let's give them a chance and see what happens here.
Surprisingly, the logs don't roll. They slide over the rails.
Sliding doesn't roll. It rolled a little bit. It rolled a little bit.
It rolled first and then slide maybe, but it slid first.
We're getting all these beams in place. They're all crooked. They're all bunched up. They slid more on one side, and they stopped completely on another side. I don't know why. But now they got them all straightened out. I think we're just about ready to go again.
The rollers tend to move like this, and they get stuck. So you can imagine that they had a big problem if they were going, like on a very steep slope, over 5%. That would be a real problem.
You see. We tried rolling. They didn't roll. They all slid. 4 are bunched up here. 3 are bunched up there. We're now going to lash them, so we simply make a sled out of it.
Well, you could see what happened when they started moving their sled. Their rollers went crooked and got all jammed up underneath the sled, so they're going to have to re-rig. And actually, it's too bad, but it's not real surprising, because the use of rollers is one of those ideas that looks great on paper, but it's real hard to make it work in the real world. So what they've decided to do is pretty clever. They're going to take those rollers and they're going to tie them to the bottom of the sled, fix them so that they can't roll anymore, but they also can't go crooked. The disadvantage is going to be, because they can't roll, there'll be more friction, but I think it's going to work better. So they'll lay it back on their rails with their moai, and then they'll just slide it down the rails. I think it'll work pretty well.
The hardest part is overcoming the inertia of 9.5 tons. Then the sled slides easily. This novel solution exploits rope lashings and wood crossbeams that are common in traditional Polynesian culture. The people of the Pacific are intimately tied to the ocean. In ancient times, outrigger canoes were the vital link between islands. The outriggers have 2 beams that extend from the side of the canoe to prevent it from capsizing. The larger voyaging canoes were simply 2 hulls bound together by wood crossbeams and rope lashings. Joanne's theory is that the same seagoing technology was used for transporting moai across land.
If you look down the length of this transport rig, you will see the strong triangular shape that we've created. And what we've got here, we've used basically the metaphor of Polynesian transport technology, which is essentially canoe building technology. So this is a wood rig pegged and lashed in the same way that a large canoe might be lashed. The cross beams act almost as balance beams on an outrigger canoe.
Polynesians made wooden ladders to aid in carrying canoes up on shore. The crossbeams of this ladder are lashed onto long rails, just like the rollers lashed to the sled for the moai.
Is we've taken the canoe ladder concept, which is essentially rails and crossbeams with the moai lashed to the crossbeams, and we've just used exactly that technology, the canoe ladder, crossbeams, rails, and it works like a charm.
Each group of statues was raised on a long rectangular platform, or ahu. According to island belief, the ahu elevate the ancestral spirits partway between earth and sky. Most ahu platforms are along the coast. The moai face inland, their backs to the sea. To have the moai facing inland on its ahu, the team resorts to modern machinery. Now they have to reposition the statue face down and then rotate it 180 degrees. Vince explains why.
Well, everybody agrees, I think, that the moai were quarried up on the side of the cliffs and were lowered down to the bottom of the slope facing out towards the ocean. And likewise, everybody seems to agree that once they got erected on the ahu out at the seacoast, they were facing inland away from the ocean. So that means that there's one movement that you can't avoid making regardless of what transport method you use. Claudio thinks that the sled was fastened to the face of the moai at the bottom of the quarry slope, and then the whole rig was lowered onto the ground for transport across the island. And if he's right about that, of course, it means that the moai was handled face down instead of face up. But whether he's right about it or not, somewhere between the bottom of the quarry slope and the ahu platform, this moai has to be rotated 180 degrees so that once it's erected on the ahu, it's facing inland away from the sea.
Now repositioned face down, the moai is rotated, but not with the tools of the ancients.
You'll notice that the A-frame is now backwards from the way it was yesterday, which they did with a crane, but I mean, doing it with manpower would be somewhat of a project. It's just a shame to see all the tricky parts done with the crane, because pulling it on the level is not easy, but it's the easiest of all the moves you have to make. And that's the one we're getting to see. It'd be interesting to see the others tried by hand, because I think that it'd be a major operation.
Vince wonders how the islanders moved the giant statues up to the ahu platforms that line the coast. He doubts Joanne's pulling method, since there is no space for long lines of people on ropes behind the high ahu platforms.
As we've seen, many of these platforms are right on the shoreline, and this is actually water out here. This is actually ocean crashing against the bottom of this wall. We have no other way to move it except long lines of pullers out here. There's no place for these pullers to work. They're all down here in the water swimming. We need some other way to get this sled up onto the platform. So watching that, it occurred to me that an improvement on this design that solves that problem would be a sled which has lots of crossbars on it so that you have many places to apply leverage. And that would, for example, enable you to get this sled up onto the platform here just using levers, and therefore nobody would be swimming out in the ocean. And incidentally, this sled works real well for the 180-degree rotation, which we've seen has to be done somewhere between the quarry and the ahu platform. If all the guys on one side lever forward and all the guys on the other side lever back, as you can see, it quite readily rotates the sled the 180 degrees.
Vince has been given one day, a half-carved stone of Raphael's, and a few leftover materials to put his new idea to practice. His sled is designed for levering a moai forward when there is no room for long lines of people pulling on ropes.
The lever was probably one of the first tools that primitive people learned how to use. It was really the only way they had to multiply the force of an individual person's muscle power.
The crossbeams act as leverage points for the men to push against.
Okay, what we're trying to do now is just demonstrate rotating the moai on this sled. And by putting skids under and having the people on one side go to the rear, the people on the other side go to the front, and the people in front and back go to each side, as you see, we can rotate it. Okay.
Well, I think it's an interesting experiment. The main problem we have here is that certainly the frame was, built without knowing the weight of the block. So certainly we have a problem there. It's tending to bend a lot. And it's not because the method doesn't work, it's simply because it was not carefully, designed for that block of rock.
The bottom line here is it's not really demonstrating very much because the design of the frame is so inadequate that we can't really make a just extrapolation from what we're seeing.
We are moving it with 14 guys, and it's a big rock, and I could hardly claim that because of that it's a successful experiment. But we've learned a whole lot of stuff, and I think we've shown that a small gang of people with levers can move a big rock. One thing that's kind of neat here, if you figure this thing weighs about 6 tons, we got 12 guys on it now, so each guy is moving 500 pounds of rock right now, each individual man. It's not too bad.
Can I make another point? I would say that to turn the moai on the frame we designed doesn't require the intricate ladder that we have here. We could have done it in a simpler way.
Vince's side experiment is beginning to raise the temperature and turn the archaeologists and engineers from critics to advocates of their own theories.
Having 3 beams for rotation, the A-frame was just as fine, as good for the rotation part.
Did you do a rotation with the A-frame?
We didn't, but we could. We could.
But you didn't?
We didn't.
You used a crane for it, if I recall correctly.
We did exactly what the experiment required.
Well, it may be. It's easy to say it's perfect for it, but if you don't do it, you don't know. I said this was perfect last night, but now I've done it, and I say, whoops, maybe
now you say it's not only not perfect, it's a mess. Look at it.
Yeah.
Look at that. That's a disaster.
Let's not tear down anything. I'm just looking at the principles. The principles are that whenever...
And by the way, I'd like to correct, to show you how poor an engineer I am, I'd like to correct a comment I made a moment ago on camera. I said each of these men was moving 500 pounds. If that's a 6-ton rock, each man is moving 1,000 pounds. Now you can call it poorly designed if you want, but you had 40 people to move 9 tons. I've got 12 people moving 6 tons. You didn't do that.
You've got 12 people turning 6 tons.
Well, we moved it too. You saw it. You saw it move. You saw it move.
I did.
Yeah.
You're right. I saw it move. Congratulations.
Well, sure.
Could similar arguments have divided the ancient stone movers?
The whole idea here, we're trying to move an 80-ton rock. You better make most use of your people.
And did the early islanders fight over the politics of moving sacred stone? During the 1600s, life on Easter Island was in crisis. The island had become overpopulated with thousands of people, all competing for the dwindling supply of food. Warfare broke out. And in the ensuing power struggle, there was growing rivalry to carve larger statues to appropriate the spiritual power of mana.
When the whole society embarked in this religious sculpture compulsion, reducing the amount of people that was actually producing food, for example, creating some sort of imbalance that at the very end led to a crisis and to the collapse of the whole culture.
Resources were quickly disappearing. The last precious trees were cut down as the demand for timber to raise and transport moai escalated. Ancestral statues were knocked down by the warring factions. In time, the population would all but disappear. The great civilization of Easter Island had collapsed. A fallen moai lies beside a stone ramp leading to an ahu platform. Claudio walks along the back wall. This ahu, abandoned in mid-construction, shows how the islanders moved their moai onto the elevated platforms.
The main device that was used to lift statues was a stone ramp.
Ramps were made from the limitless supply of lava rock scattered all over the island. Ascending the stone incline, a moai would finally arrive at its high pedestal stone, which often overlooked the sea.
This statue was going to be placed in that ahu using the ramp just described, and we know that the process was never finished because the eye sockets were never opened. Moais are completely finished at the quarry several miles from here, except for the eye sockets, which were open when the moai was erected on top of the ahu. At that very moment, it became alive and acquired the supernatural power and the ability to communicate to the ancestral world.
At the beginning of another day of testing Joanne's moai transport theories, Vince surveys the ramp that was made for the experiments.
So Claudio, the way I get it, the platform out at the end where those guys are standing is what remains after the project, but this is just a construction ramp, is that right?
Most probably, statues were approached to the platforms using this run.
Sure, because in most cases you can't get to the platform from the rear anyway because of the sea walls and so forth.
Yeah, they're very close to the coast,
sure.
And most of them have very high back walls.
Gotcha.
Seaside walls.
Right.
So most probably.
Today's goal will be to transport the moai up the ramp, which is paved with laterally placed logs. They start on flat terrain in front of the ramp. More logs are brought in and placed in position like the ties of a trackless railroad bed. It takes a lot of trees to make a wood road just 30 yards in length. It seems plausible that the trees of the island could disappear altogether in the act of moving sacred stone. Thick palm forests blanketed the island when the first settlers arrived. Pollen analysis shows that a species of palm strong enough to move moai, called Jubea chilensis, once flourished here. In their escalating efforts to move and raise giant statues, the islanders cut down the last of their trees. Long before the first Europeans arrived in 1726, the island had been stripped bare. Not one Jubea chilensis palm tree remains today. Could it have been the obsession with erecting giant statues that led to Easter Island's ecological and social catastrophe? The next day, the team faces the challenge of moving the moai the last 6 feet to the pedestal stone. Joanne's team will now test a different method that gives extra mechanical advantage to the moai movers. The team has been reduced to 20 people.
They've actually done something quite clever here. What they've done now is they've tied the rope from the sled to a lever, a big lever beam, and they've got a big crew over here pulling the lever beam with a rope attached much higher on the pole. And the reason that's so smart is because they get a huge mechanical advantage. In order to move the sled 1 foot here, they'll have to pull 4 feet here, but they'll pull with 4 times the force. So in effect, it's like quadrupling the number of people pulling on the load. So as they pull the pullers back here, they basically have 4 times the force working on the sled by doing it this way.
It's a good method. We needed a stronger method.
I was waiting for something to break.
Well, we were all
we
waiting
can learn from it.
We were all waiting for that.
It was
we got
good.
it here. So.
With a smaller workforce, it has taken an entire day to move the final 6 feet. The last few days of experiments have led Joanne to conclude that there may have been more than one method for moving moai.
I have learned that the statues lend themselves very well to manipulation. They're well balanced, they're well designed, you can attach rigs to them, you can change them. I think people would think on their feet and develop methods for moving these statues that were adapted to each individual statue.
Many moai on Easter Island had topknots known as pukao placed on their heads. They are thought to signify the headdresses that Rapa Nui chiefs wore. Red cylindrical pukao lie near the fallen moai all over the island, and they were carved from this ancient quarry of red scoria stone. Raphael carves an authentic pukao for the replica moai. He uses a basalt toki, the tool used by the ancient sculptors to carve island stone. Raphael passes on the age-old technique to Santi.
Raphael says it is the scoria rock which is used to make the pukao because it is light and people are able to take this pukao across the island to different sites and place it on top of the moai.
Rapa Nui society supported specialist craftsmen. The master carvers held an elevated status in the community.
So there were master carvers who were dedicated to just carve pukaos. They never worked with the rush of time. There was no time frame. It's all based on mana and religion. And in our modern time, we'll succeed, I think.
The team must now figure out how to raise the moai. They use levers to lift the load inch by inch, while stones are carefully placed underneath. Slowly, the moai will be jacked up to a vertical position. The pukao is now ready to be added to the load. Not all moai had pukao, and we don't know how the islanders raised them onto the statues. The Rapa Nui men devise a simple pulley system for rolling the 1-ton pukao up the short ramp. Pukao and moai will now be joined together by rope and secured for the raising.
Tomorrow we'll see them levering it up, how easy it really is, and it should go very quickly. I think this is the way it was done.
I'm not sure. I mean, it's also possible. It's possible to raise the two together, but it's also possible to raise the statue first, and then if the statue is deserving of a pukao, maybe then they put the pukao second.
But the problem is when you do the statue and then do the pukao, you have to do everything twice. This took days, and then you have 2 more days of doing it.
Claudio is the archaeologist in charge of the raising. He hopes the moai will be raised in 1 day.
By 3 o'clock, it's going to be very high, but 4 o'clock it should be up. 5 o'clock. It's not a promise. So now those logs now are not.
The work takes on its own rhythm, and a steady stream of ideas come from the onlooking experts.
3 points at least. I mean, the wood is helping.
It's in good position.
The pile of rocks jacking up the moai gradually grows higher. Zvi measures the team's progress by calculating the moai's angle of incline.
30? Exactly 30.
You're off.
How much?
We're going to go with about 34.
Oh.
What's if you take the angle of the blade from the
They are using the same instrument, but somehow cannot agree on the angle.
It's pointing exactly at 30. What do we approximate? It's exactly 30.
We got about 31 degrees and 24 seconds.
Yeah.
Now it really moved. From about 30 degrees, we're now approaching probably 40. And at 45 it will be much lighter. So now it's really going to go up very fast.
35, went up 5 degrees.
The statue of the frame.
I go by the frame.
No, and I go by the statue because the angle is different. I'm reading about a little bit over 40, maybe 42. But pretty soon, one more time, we'll be up at 45.
Well, I gather from Svi here that it's about 43 degrees now. You know, mathematically, once it gets beyond 45 degrees, it should get easier rather than more difficult. You know, so getting to here has been the hard part. And as you get nearer and nearer to vertical, and you have less and less weight on the rock pile, that's when it gets quite easy to set the stone upright, but it's hard to control because you don't have the friction of the load leaning against the rock pile.
With a growing rock pile to clamber over, the men find the work tricky and the moai unstable. Zvi becomes even more interested in their rate of progress.
49.
There are now fewer levering positions on the 12-foot pile of rocks for the 20-man workforce. They must all find a place on just 3 levers. With the daylight fading, the work will have to continue in the morning.
My biggest concern now is that because we're running out of light, and it's quite late, and the moai moved a little bit to the right, and we have to be very careful because that's the critical angle. We might lose the statue. So we have to secure everything tomorrow, put it straight, and control these rocks around it so that the people will work safely at the same time. But it will happen. I mean, it's not a problem. That's just a little disruption in the general process. But it's going to go up, no problem. In 2 movements, it should be up, but we have to go very slowly because it can come with all the way this way. But certainly, this is the most critical point.
61, approximately.
Work is soon stopped. Zvi's obsession with the angle gets beyond Claudio's patience.
If this is 65...
65 degrees with reference to that, to what?
The 65 degrees is the angle of the base relative to the horizontal, to the horizon.
I mean, you mean this angle here?
Yes.
That's 65?
Yes.
No way. That's not even 45. I don't know what you're talking about.
Oh,
not 65 degrees this way. Come on.
I'm measuring this angle here.
I mean, no, I'm tired of this bullshit.
It is a simple misunderstanding.
Shit.
Great efforts will often bring out great passions. Time, effort, and resources are all at play in this arena of larger-than-life stone moving. It is a delicate moment. It must be played out with brute force. Claudio and Raphael watch for signs of twisting. We may never know how the moai were moved or raised, but by a revealing stroke of fate, the methods tested here have taught us as much about ourselves as about the ancient Rapa Nui.
Well done.
After all this fighting and all that.
It took a lot of headbutting and arguing and compromise, but it's a very creative process. It's a process that probably they went through in part in the ancient times. The bottom line is we will never be able to reconstruct with total authority exactly how they did it.
We learned a lot here, I think, through the process of trial and error. I mean, we tried a lot of things. Some of them worked, some of them didn't. Even using a crane for some of the difficult moves, this was not an easy process.
I came here with a process in my head that I was going to try something, and I'm going away with more questions than answers, as I always do. But it wasn't until I saw all the people lay hands on this statue, which started out as nothing more than a cement piece, did I understand fully what it means for a statue to take on cumulative history of all of our efforts. All the power of the carvers, all the power of the masters who moved these things. They became the families they represented.